Hey there, please hold my beer, cause today I'm gonna show you how to win a crypto lotto. Well, maybe a bad one, the good one gonna be hard. Joking aside, today we're gonna talk about randomness on blockchain and the security concern about each of them. Before we move on, let's talk about what is a good lotto or good randomness. We want it to be fair, we want it to be safe, and preferably it should be transparent. We should be able to understand each step and how secure and how fair it is. Moreover, we might want it to be flexible. You might want to have the result and be able to do a bunch of things with it. Decentralization is also a good thing. You might not want to rely on trust on a central party. If the data written on chain, it would be easier to interact with other smart contracts and so on. Apart from this, we might want to control the cost. You might not want to pay like 100 or 1,000 bucks to do each random. Sound good enough, right? But that's another part to this story. We talk about randomness on blockchain, so the blockchain part. Today we're gonna mainly focus on the EVM. For those who don't know, it's basically the thing that run behind most of the smart contract blockchain. And for those who know, apologize for not mentioning the technology behind your favorite chain. Anyway, let's talk about the property of this system. First of all, it's deterministic. What it means is like because computer system follow instruction, if you have the same thing, the same input, the same action, you're gonna get the same result every time. So this is gonna make things slightly harder to make a proper randomness on any computer system. Up next is the atomicity. This one is shared among a bunch of database. What it does is like if there's a certain set of instruction, it have to complete all of them or none of them. So if you go halfway through and it fail, it go back to way before the first thing happened. This is a good thing in the database because you don't want to go halfway and corrupt the data. But this can also be used against you in this randomness exploit later on, as we'll show you. The next thing is like this public blockchain is public. It's kind of in the name. So people can see inside, people can copy and paste it on their local machine, people can inspect all the variable, either there's like public one or the private variable, they can kind of inspect it anyway. And there's a bunch of specific things that make things slightly harder, slightly more expensive, and you technically have to pay for gas for most of your thing that you do on it. Okay, with all this out of the way, let's start on a different design. First of all, we're gonna start from the easiest. So, if you can probably store the data out of the chain, it's like you have a private server that store result of like number one, number two, till the last number that you're gonna sell your lotto. And then on the blockchain, when you buy lotto, you just assign number to people. The first one in get number one, the second one get number two. This is actually a surprisingly common way to do things for like NFT that like you buy like there's 10,000 NFT and you just randomly get the result. And then how it works is like let's say OpenSea come in. Let's please see that logo as OpenSea. They just like look at your contract. The contract just point to somewhere off chain that like okay, this Mr. A got number one. The data for number one is over there. Go look at it. OpenSea, go look at it, and you're fine. Everything is working. At this point, you can probably guess that there's gonna be issue with it. Sure. So, can you guess? Yeah, it's pretty easy, right? If you wanna exploit this style of randomness, you can just go into the smart contract, look at where the data is stored, go to where the data is stored, and look at it. So, let's say in this case, 420 might be high, rare, and 69 is gonna be great. So what you can do is like you just wait for the 68 to go out, you go in, and now you get 69. Yeah, done. This might sound weird, but actually a lot of NFT projects implemented this way because it's simplest way to do it. Okay, but you might wonder, can the dev do anything better? Yeah, sure, of course. Can you hide the result from someone that try to look at it? Yeah, it's super easy. You just turn the server off. Just not point your smart contract to the real server or do anything to hide the result. No one know the result. There's a few good thing about this. The obvious is like because it's not available, no one can cheat, no one can know about it. The side effect of this is also no one know the result beforehand or even after they bought it. So it might not affect the floor price. So the OpenSea gonna show it as like unknown or something or just like placeholder, and people can speculate about it a bit more before the floor drop. Okay, is it done? No, of course not. You see the timestamp, the video go a lot longer. So the problem is like if this one is centralized around dev, right? You have to trust them. If maybe you're a malicious actor, you just go to the dev and ask them to give you the super rare and maybe share the profit or do whatever, and then boom, the devs are pretty much free to switch things around since no one know the result and no one gonna notice. Okay, but can we do anything about this? Of course, yes. We can try something like the commitment scheme. So basically, the dev have to hash the result and then publish it. So what the hash does is like it get the same hash from the same input, and if you change the input, you get different hash. What you can do is you can double check when with the final result whether it's the same thing that the dev commit. So if the dev change the result and give some special tweets to dev special someone, the hash of the new result not going to be the same, and you can check whether the dev is cheating. But well, can people still cheat this? Of course, same thing. You just go to the dev instead of asking, give me like the super rare. Just ask dev that like which one is the super rare and just go buy it. Job done. Apart from the security issue that I mentioned before, all of the previous design also share the same limitation that the data is off-chain. What this means is to other smart contract, what it can access is only the token ID. So the rare one and the common one would look really similar to another smart contract. This wouldn't be ideal. But there's a few things that we can do about this. The easiest one would be to just write data into the chain. So to do this, maybe you just assign admin that can write data into your smart contract. So after someone buy number one, you do the random, you know that it's rare, you write rare or write some data, and that's it. It's pretty easy. The problem with this is like you have to pay gas every time you write something into a blockchain, which might not be ideal for you. The second option is like you use some cryptography to confirm that you approve the data. So the flow gonna be slightly more complicated. Let's say maybe someone buy a lotto, you do your math, your calculation, your logic, and you just sign a message confirm that the result of the lotto is this one, and then the user can write that one into the smart contract, and your smart contract is just double check whether you actually approve the result. This slightly more complicated, but now you don't have to pay for the gas. Another issue with all this is like it's pretty centralized, right? All the previous option is based around some dev that do something outside of the blockchain. So how about we write the randomness into the smart contract itself? And now you don't have the complicated off-chain setting, and you also can rely on the decentralization of the chain. From this, as I mentioned before, that the computer system don't have any built-in randomness in itself, so you have to provide some source of randomness. So you can put something that might be hard to predict in your function, let's say a hash function to get let's say that look random. But if your source of randomness is really predictable, it's really easy to figure out what the result might be. For example, if you put like ID in, you already know that what is the next ID. You can reproduce the whatever you're gonna compute, and you already know what the result is. The better practice would be to push something that like really hard to predict into the function. For example, block hash, which gonna change every block, or price of something that might be changed between the block, or something else that you can come up with. This might sound like it's more secure, but still there's a few ways that you can exploit this. The first one is like you can exploit the atomicity of the blockchain. As we mentioned before, it have to go through all the steps, otherwise it's gonna go back before the first step, right? So you can write a smart contract that do a few things. Let's say first step, buy the lotto. Second step, look at the lotto result. And the third step is like, if you not win, you just revert, make things earlier, make things go back before you buy the lotto. And then you just keep repeating this until you win. So it's actually not gonna cost you that much because you're not gonna pay for the lotto cost because it's gonna revert every time you not win. But you still have to pay for gas and deployment costs and so on. So it's not the cheapest exploit ever, but it can be done, especially when the price is high. Another way to exploit this is to use the fact that it's actually public. What it means is like you can just copy the whole blockchain into your machine, and then you can play around with it until you find a way to win. Let's say you have to submit at this precise time, precise block to win the lotto. You just do it on the actual chain, because anything that you do on your own machine, you're not gonna cost anything, right? But this kind of exploit is not risk-free, because like if the designer of the contract have some randomness that could be changed over time or hard to predict or hard to control, even if you know the thing that might win, by the time you submit the actual transaction, it might already change. But still, this kind of exploit gonna give significant advantage to the exploiter over regular user, which is not ideal at all. Okay, but then, are there any better way to do this? Yeah, there is. Don't give up yet. So there's a few ways that you can do to improve all this. There's some work that already done. For example, there's a VRF function from Chainlink. By the way, I'm not getting any sponsor from them. Anyway, how it works is like user have to submit the transaction first. The smart contract can request a randomness from Chainlink contract, and then the transaction is done, saved to the chain, and then the system gonna take the some sort of randomness from the request, some sort of randomness that happened after the actual transaction, and then combine with a few other things. They do some magic, and then they push back to the smart contract, to Chainlink smart contract. They do some verification that no one tamper with the result, and then push the randomness back to your smart contract. From then on, you are free to do anything with the randomness that you receive. Give out lotto reward, give out NFT, give out all the different things. This way, that's a feel good thing because it mitigates all the problem that we mentioned before, and so on. But there's a few downside to this. First of all, there's a cost associated with this more complexity in the system. Either you have to pay link to do it, or you have to implement this thing yourself, which also might be hard and might be expensive. Another part is it make your smart contract a bit more complicated. I mean, it's not that hard, but like it's not that straightforward either. But I mean, Link have some tutorial about it, so maybe you can look at it and maybe modify their code. So it's gonna be fun. So I think that's it. I think this is the best way so far that we have. I mean, most reliable way so far on randomness. Okay, off to the end note. Actually, most of the way that you can design the system, there's a pro and con, and there's some trade-off. You always want to pick the method that suit your use case, and you have to know what use case you're doing and what is actually want. Let's say if you want a high security, you have to pick the high security. If you want a simple one, you pick the simple one. That's it. So I'll do a quick rundown of all the method before. The first one is just the basic one, right? It's pretty simple, pretty easy. If you have a use case that's kind of pretty chill, you might prefer this one. The next two is somewhat centralized, but like, I mean, if your use case is centralized, you trust yourself and so on. It's actually quite secure in the sense that if you're not cheat yourself and if you're not messing up, it's actually okay. And then to push the data onto the chain, I mean, I would recommend the side message method because like it's somewhat a best practice that people go for right now. If the chain is pretty cheap, it's okay for you to just push transaction yourself and then move on to the on-chain randomness. If you do it in the atomic way in one transaction, even if it's exploitable, it's actually not that easy and not that cheap. So as long as the attack cost is higher than the reward or something that make it not making any sense to attack you, you should be fine. And then if you're going to do a $1 million lotto, please use something that's secure. That's it for tonight. Have fun.